Good day, grade 12s. This is Mrs. Smith, and we're going to start with solving triangles. So using trigonometry, let's start with what we first learnt in grade 10. In grade 10, the things that we learnt could only be used for right-angled triangles. And that is to remember that if you are going to use what we all call SOHCAHTOA, they have to be right-angled triangles. Next thing that we learned in grade 11, and this could be done in any triangle. These formulae will be on your formula sheet in some format. If you want to use the sine rule, you must have two sides and the not included angle, or you must have two angles and a side. If you want to use the cos rule, you have to have three sides. And if you want to use the cos rule, you could also have two sides and the included angle. Lastly, the area rule you generally use when you're trying to get the area. And the thing you need to remember here is it's going to be two sides and the included angle. So what I mean by the include angle, if I've got two sides, the included angle is the angle in between those two sides. It's included. That's what we mean by the included angle. Now, what makes grade 12 slightly different is that in grade 12, we move into 3 dimensions. And 3 dimensions is typically okay, but you've just got to remember to look at the picture in 3 dimensions. So, for example, both of these pictures here actually represent the same thing. You're just looking at it from different angles. So you've got to remember when you're looking in 3 dimensions to imagine it in 3 dimensions to make sure that you're seeing the angles correctly. So for example, in this question, if we say that PQ is a flagpole, so obviously if the diagrams are the same, PQ would be a flagpole in both cases, which means it is actually perpendicular to the ground. Now that really doesn't look like they're 90 degrees, but they are because you realize you're looking at it in 3 dimensions. We're dealing with 3 different planes here: a horizontal plane, a vertical plane, and an inclined plane. So the horizontal plane is this shaded one at the bottom. Vertical plane, we've got 2 triangles in the vertical plane. This one here on the side, the vertical plane is at 90 degrees to your horizontal plane. And then lastly, the inclined plane, which can cause quite a lot of confusion. It is at a slope or at an angle, and that would be the inclined plane. Now that inclined plane does cause a lot of confusion because you land up with weird things like P1 and P2 not equal to that whole angle there. And the reason why is because the full angle RPS is in the inclined plane and P1 and P2 are both in the vertical plane. Another thing that you need to be aware of is if you have a look here at those 3 angles, they look like they should add up to 360 degrees, but remember 2 of them are 90 each already. And Q3 clearly can't be 180 degrees. So remember that that's like the corner of a room. It is got 3 different surfaces meeting at one point, and it is not a flat surface. Let's have a look at an example. Example 1. In the diagram, AD represents a flagpole of length 5 meters. Now, whenever you do a question, make sure you read what I call the blurb or the story. Have a look at it and make sure all the information is there. So they told us that AD is 5 meters, and yes, that is there on my diagram. They then tell me it is perpendicular to the horizontal plane. So let's make sure we don't forget that, and I'm going to put that in 90 degrees. An observer at C notes that the angle of elevation of D is 35 degrees. So 35 degrees, that is on there. while another observer at B notices that the angle of elevation of D is 42 degrees. And then lastly, they told us that BAC is equal to 65 degrees. Now that I know all the information is on the diagram and I made sure I understand what's happening, I know that there's a vertical pole, we can now carry on with the questions that they asked. What is the size of angles DAC and DAB? That is something that we answered while we were going through it. They told us that it is perpendicular to the horizontal plane. So straight away I know that DAC is equal to DAB is equal to 90 degrees. The next question, how far is each observer, B and C, from the foot of the flagpole? So here, they're asking for that distance there. The triangle that is connected to that line that has the most information is DAC. So you should always be looking for the triangle with the most information. They also asked for that distance there. The triangle with the most information is that one there. If you see, both of those triangles have 3 pieces of information. They have an angle, they have that it's a right angle triangle, and they have that length AD. So now that I know which triangles I'm going to deal with, I go to triangle DAC. And in triangle DAC, because it's a right angle triangle, I can use my grade 10 trigonometry, which is SOHCAHTOA. And I see from the angle, I've got the opposite side, and I'm looking for adjacent. So if I'm looking for opposite and adjacent, SOHCAHTOA, opposite and adjacent tells me I'm going to use tan. So tan of 35 degrees is equal to 5 over AC, which then gives me AC is equal to 5 over tan 35 degrees. You type that into your calculator and you find out that AC is a length of 7,14 meters. The minute you've worked something out, put it in on your diagram because you might need it for a later question. In the other triangle, so in triangle DBA, okay, again, we've got the opposite and we're looking for the adjacent, so we're going to be using tan. So this time it's tan 42 degrees is equal to 5 over AB. So AB is equal to 5 over tan 42 degrees. And if you type that into your calculator, you find out that AB is equal to 5,55. Put it in on your diagram. Remember, when you're doing these, your calculator must be in degrees. Okay, don't forget that if it's in the wrong thing, you'll end up getting the wrong answer. Let's have a look at the next question. Question C. Calculate the distance between the 2 observers at B and C. So you can see here my diagram has all the information we've worked out so far. They're asking for the distance between the 2 observers. And again, there's 2 triangles here. We can use this triangle, which I'm highlighting straight away because I can see I've got 3 pieces of information in that triangle. I could also use the big slanted triangle DCB. DCB, the inclined triangle. But on that triangle, I actually don't have any information. So instead, I'm going to use in triangle ABC. And I've got 2 sides in the included angle, so we're going to use our cos rule. So BC squared is equal to 7,14 squared plus 5,55 squared minus 2 times by 7,14 times by 5,55. Cos of the angle is 65 degrees. Now something you'll notice, this angle and the side that you started with are always opposite each other. From there, we can start working it out by typing into our calculator, and we get that BC squared is 48,29. Keep the answer in your calculator. Do not round off early, and do not forget to square root. And when you square root that answer, you get that BC is equal to 6,95 meters. Fill it in on your diagram. When we square root, we normally take positive or negative, but here we're talking about a distance. So we know we have to be referring to the positive answer. Our very last question, calculate the area of triangle ABC to the nearest whole number. Okay, so area of a triangle, we are looking specifically at this triangle at the bottom again. The area of a triangle can be half base times perpendicular height. And please don't forget that formula, because sometimes it's actually more useful. But in this case, I don't have the perpendicular height. So I'm going to use the area formula that we have in trigonometry. And remember, we need two sides and the included angle. So if this is the angle that I've got here, then I have to use the two sides that make it included. So the area of triangle ABC is equal to half 7,14 times by 5,55 sine of 65 degrees. We type that into our calculator and we get an answer of 17,96. Make sure you answer the question. They said to the nearest whole number, so that gives us 18 meters squared. You now need to do exercise 1 from your textbook, and good luck.